Welcome to our presentation tonight. We're really excited to have Ms. Andrea Portt and Dr. Christine Lay with us. We are a federally registered charity supporting the 5 million Canadians living with migraine and headache disorders. Our mission is to improve the lives of people with migraine and headache disorders through our 5 pillars: advocacy, awareness, education, research, and support. Just a quick side note that our remaining Q2 webinars are posted on our events page, and we've launched our annual Move for Migraine campaign. So please, you can also check that out on our website as well. And so now to introduce our presenters, we have Dr. Christine Lay joining us tonight. Dr. Lay is a professor of neurology at the University of Toronto and is the founding director of the headache program at U of T, holding the Deborah Ivy Christiani Brill Chair for Neurology Research. In addition to building the headache program, training fellows, as well as a very busy patient practice, Dr. Lay is actively involved in research, teaching, and advocacy, serving as the chair of the American Migraine Foundation and as a board member for both the American and Canadian Headache Societies. Tonight, we also have Ms. Andrea Portt, PhD student. She is a PhD student in epidemiology at the University of Toronto. Her research passion lies in deciphering the impact of environmental exposures on neurological health. Under the mentorship of Dr. Peter Smith, Andrea's doctoral research focuses on the innovative use of mobile app data to unravel links between air pollution and migraine. And with that, I'm going to turn it over to our presenters.
Well, let's get started then. Thank you so much for that introduction. It's really an honor for Christine and I to be here, and nothing makes migraine researchers happier than having a chance to share our research with the findings who are living with this condition. So just to give you an overview, I'm going to start by talking a little bit about why we were interested in studying air pollution with relation to migraine, air pollution as a migraine trigger, why we carried out this particular review that I'm going to talk about, what we found and some of the limitations, practical implications, future directions that we're working on, and finally acknowledgements. So, why study air pollution with relation to migraine? Well, to start with, we know that patients and clinicians have questions about environmental exposures like weather and air pollution that we don't have answers to yet. And also, as you can see from in this poster from the World Health Organization, it's something that we're almost all exposed to. So if you think about 92% of people in the world breathing unsafe air, then a small increase in migraine attacks per exposure could be a very large number in the end, especially when you also consider that more than 1 billion people worldwide are living with migraine. And there are also things that we can do to prepare for or to reduce air pollution exposure that we'll talk about more later. So in terms of how we think air pollution causes migraine, we used to really, I know growing up, I thought of air pollution as something that hurts your lungs and your heart. And now we know that air pollution actually impacts multiple systems in the body. So the pollutants I'm going to talk about today are particulate matter, sulfur dioxide, ozone, carbon monoxide, and nitrogen dioxide. And we have this beautiful image that was published in Catherine Offord's Scientist article in 2019. And it shows 3 different ways that it's believed that air pollution can reach the brain or affect the brain. So the first way is through the olfactory nerves, which are the nerves at the back of your nose that help you smell. And it turns out that some pollutants can travel right along those into the brain. Secondly, sort of the more traditional way that I definitely thought about air pollution is absorbed through the lungs, and they can then either cross the blood-brain barrier or just trigger changes in the blood that impact the brain. And finally, another route that I had never thought about before I started this research and learning about it is reaching the gut through swallowed air. And then air pollutants may be absorbed into the bloodstream, or they may impact the gut microbiome. The biological mechanism or biological connection between air pollution and migraine, we're actually learning more about recently. So there's some work that's been done at Southern Medical University in Guangdong Province, China. And Ye and others have looked at rats that were exposed to nitrogen dioxide. And they looked at the gene expression in the rat's trigeminal nerves, which are the nerves that run from the back of the head to the sides of the face that are associated with migraine in humans and migraine-like behavior in rats. And what this group found is that following exposures to nitrogen dioxide, there were actually changes in gene expression in a migraine-related pain and inflammation pathway, which is the same pathway that anti-CGRP and triptan migraine medications block.
Andrea, I think the slide didn't move.
Oh yeah? What slide are you seeing
We
now?
saw the Catherine Offord's drawing.
Let me. Okay.
Again, okay.
Thanks, Christine. So sources of air pollutants are transportation, industry, agriculture, and energy are some of the main sources. For example, nitrogen dioxide, sulfur dioxide, and carbon monoxide. Major sources of those are burning fossil fuels. And then nitrogen dioxide actually goes on to react in the air to create ozone. Particulate matter is kind of a funny one because it's not actually chemically defined. So it can be any tiny airborne particles from sand and dust to fuel-related medical particles in the air. So major sources of particulate matter are roads, fossil fuels, construction, and agriculture. Now, that being said, all these pollutants normally occur in mixtures, and the concentration in the air can vary depending on the wind, sunlight, the temperature, which is important for this research because we know that some of these weather factors can also impact migraine. So we need to take weather into consideration in these studies. So we carried out this systematic review to see what work has already been done and to find out if the results in different studies and different locations agree with one another. Interestingly, a number of these studies to date have actually been done in Canada or with Canadian researchers. So this slide's an overview of how we narrowed down our search, and I'll explain it without getting into too much detail. So we started out by searching broadly through different scientific search engines, and we came up with 124 different articles that might be related to air pollution and migraine in that search. Looking through the citations and the references in those searches or in those articles, and also with weekly updates, we found another 6 articles. Once we'd found all those, my friend and colleague Krista and I read all the abstracts and ruled out studies that either weren't related to migraine or didn't quantify air pollution or migraine or were sub-analyses of different papers that were going to be included. And in the end, we had 12 studies to include in the review. We then assessed the research quality for those 12 studies using the World Health Organization's Air Quality Assessment Risk of Bias Domains instrument, and we extracted data and looked at the results from the studies. So this figure is a summary of our risk of bias assessment. And you can see from all the green on this side of the figure that there was generally high quality in the methodology of the studies. One limitation that we bumped into around this point is that there were a wide variety of pollutants and of ranges of exposures, a wide variety of outcomes, which were mostly clinic or ER visits, but also prescriptions and diagnoses of migraine, and also a wide variety of study methods. So because of all those differences, we didn't try to combine the results and come up with sort of a true result. but instead looked at the results side by side to see if they agree with one another. So this is our summary of results from studies that examine the association between nitrogen dioxide and migraine outcomes. And as you can see, there are differing ranges of exposures in the different studies, which is mostly that's related to being in different locations. There are also a wide variety of migraine-related outcomes, including ED, as in emergency department or emergency room visits, diaries, neurology visits, and prescriptions. Now, interestingly, despite all that variety, overall, most of the estimates were positive, or we say above 1.0, which suggests that there may be an association between exposure to nitrogen dioxide and new migraine or migraine attack onset. The numbers here to the right of the estimates in brackets are the 95% confidence intervals. These basically mean that the authors expect that if they repeated their studies, the estimates would fall between these numbers 95 out of 100 repetitions. So it's a measure of certainty. And as you can see in these results, about half of the confidence intervals include the null value of 1.0, meaning that there is some uncertainty in this work. So overall, when we looked at the different pollutants that have been examined, we found that the strongest and most consistent associations were with nitrogen dioxide and migraine. That was followed by particulate matter and ozone, whereas it was less clear or there were simply less to go on for carbon monoxide or sulfur dioxide. And since August, when this was published, or when our review was published, there have actually been 2 new studies and 1 new systematic review. And those studies and the review broadly agree with the results of our review. One of the studies is this work by Dong and others. Their team used data from a big resource called the UK Biobank, and they linked the incidence of new migraine to air pollution. And they actually estimated that about 14% of new migraine cases that developed in the higher pollution environments or areas in the UK were attributable to combined exposure to particulate matter, nitrogen dioxide, and nitrous oxides. Whoop, oh no, I didn't skip. Okay, good. So practically, what can we do with this new information? Personally, if we're living with migraine, we might want to try to reduce the potential impact of air pollution on our lives, which sounds great, but as we all know, breathing is not optional. So there are some things you can do. For example, choosing active transport, choosing streets with less car traffic to walk on, using air purifiers. And we can also prepare for exposures and take preventives or take preventive measures like we do for other unavoidable migraine triggers. But really the big improvements in air quality come from policy change. There is good news on that front. As you can see from this poster from the World Health Organization, in the Americas, our exposures are actually declining due to policy changes. And the pollutants that we're looking at here are either or piggyback with greenhouse gases. So the fact that current and pending policies put Canada on track to cut emissions of greenhouse gases to 35% below 2005 levels by 2030 is potentially really good news. I mean, it's already really good news, but this could be another reason it's good news. So as I mentioned, big air quality improvements come from policy change. That means that voting and advocacy are important. Consumer choices are important. We have this infographic that describes some of the solutions. So air quality can be improved by investing in energy efficient power generation, improving domestic industry and municipal waste management, making greener and more compact cities with energy efficient buildings, reducing agricultural waste incineration, forest fires, and certain agroforestry activities, providing universal access to clean, affordable fuels and technologies for cooking, heating, and lighting, and building safe and affordable public transport systems and pedestrian and cycle-friendly networks. So in conclusion, it increasingly looks likely that air pollution triggers a portion of migraine diagnoses and events. So along with known benefits to the planet and respiratory and cardiovascular health, it's possible that ongoing reductions in pollution may help some of the millions of Canadians who are living with migraine. We do have some future plans along these related to this project on the go. So since a major source of information on air pollution and migraine to date has used ER visits, we want to learn more about why folks visit ER for migraine and what barriers they experience. We had a survey sent out this past fall, and there were hundreds of responses, including many from the Migraine Canada community. So thank you. And the results from that work are going to be presented in May at the Canadian Neurological Sciences Federation Congress in Toronto. As well, we have a study ongoing to determine potential associations between air pollution and migraine in Ontario, using daily air pollution data from Environment and Climate Change Canada, which will give us better location precision than previous studies have had available, and also daily reported migraine events from research consenting smartphone app users via our collaborators at Migraine Buddy. And this work will be presented in August at the International Society for Environmental Epidemiology Conference. And we hope to end up with a more precise estimate of how individual and mixed pollutants can interact with migraine. Here are my references that are available if anybody would like them. And with that, we'd just like to say thanks to everyone who's here, to Migraine Canada and the Migraine Canada community. It's such a wonderful opportunity and honor for us to be able to share what we've learned. I'd like to thank the research team. So Krista for going through all those titles and abstracts and combing through the data with me. My fantastic PhD committee, Christine Lay, Erjia Ge, and Hong Chen, and my supervisor, Peter Smith, who's given me the freedom and support to explore these questions, as well as the Dowlana School of Public Health and the Dowlana School of Public Health Data Science Interdisciplinary Research Cluster at University of Toronto. Their financial support makes this work possible as well.